You don't know.
Hey, you're strong.
Oh, you don't?
Be inside thought. Don't you
Yeah,
get
it's
so
not
mad.
bad if I do. Huh?
So I got extra credit.
Yeah.
No.
I doubt it though. Okay. Okay. So let's talk about, yes, there's backside fin. Okay. So part 4. So here's what you've got. So I kind of have this set up. So what's going to make this different is, number one, they're going to use 4 different particles. Okay. So, and I lay this out, and it really doesn't make any difference where. I'm just saying, hey, this is kind of like the general location. So you're going to put a positive charge at some point. Okay, I don't care where you put it in an intersection. I'm going to call that 0, 0. Okay.
He might punch you again.
Then you're going to stack 3 negative charges. So basically what you're going to make is a square. 1 positive charge in the bottom left corner, and then you're going to have negative charges at the other 3. Make sure that you know where 1 meter is on these grids. You cannot just randomly place these. For this to work, these need to be exactly 1 meter apart. And they need to be exactly 1 nanocoulomb. So, what you're ultimately going to try and do is that you're going to determine the value of the electric field at point X, which is in the exact middle of these 4 charges. So here's what you've got. So you've got a negative charge here, a positive charge here, a positive charge here, and a positive charge here. Okay? So,
Wait, I thought those were negative charges.
I'm sorry. Those are negatives.
Okay, I was like, what?
That's the positive, the other ones are negative. My bad. It's my bad. In my inside thought, I was saying they were negative. So, I got a negative value. So, here's what's important, and here's the difference between forces and fields. Okay? This is one of those common misconceptions that happen. The difference between the 2 of them. If you look at how you calculate an electric field, and there's a whole bunch of different ways, this one we're going to start with KQ over R squared. So to determine the value of an electric field, that's only based upon 1 charge and what's creating the charge, okay, or what's creating the field. So field calculations are only based upon 1 value of charge. Okay? Got that? If you were to calculate forces, you'd have to have K Q1, Q2 over distance squared. So the reason that I can't calculate the force that's happening in the middle of that, I don't know what the value of the test charge is in the middle. Okay? So this is why I can't calculate the net force in the middle, because I don't know what that force is. Okay? Now, think this through. What do you use to determine the direction of an electric field? A positive test charge or a negative test charge? Positive. So this is what I'm going to begin to lay out the thought process here. Okay? So all of these are 1 meter apart. Okay? 1 meter, 1 meter, 1 meter. You're trying to find a point right here. Okay? Now, let's just think this through. If I put a positive test charge in the middle, and that's how fields are defined. If I put a positive test charge in the middle, what's it going to feel from that positive test charge in the bottom? It's going to feel a repulsion, so it's going to feel pushed this way. What's it going to feel from the top right negative charge?
Attraction.
That's going to feel an attraction. Okay? Everybody cool with that?
Yes.
Now, what's that positive charge going to feel from that negative charge in the bottom?
Attraction.
It's going to feel attraction. What's it going to feel towards that other negative charge? So what do you think is going to happen to those two values?
Cancel.
Those are going to cancel out. You don't have to worry about those.
I
Okay?
was just gonna. We got 2 and it's gonna drop right.
Okay? Now, so there's a couple of things that are going to be tricky about this. Number one, you can't calculate the force because you don't know what the test charge is in the middle. All you know is that it's a positive charge. This is why I'm not asking you to find the value of the force. I'm asking you to find the value of the electric field. Now, you need two things to find the value of the electric field. You need the charge that's creating it, and you need the distance from the point source. Okay? So, because this is right in the middle, what are the two dimensions of that triangle? 0.5 and 0.5. Okay? So you need to find that hypotenuse. Now, here's what you need at part 4 where I said EX. Okay? When you get done with that calculation, you need two parts to this. You need what you think the magnitude of the electric field is going to be and the direction of that electric field. Okay? Once you get that done, come up the Viceroy voltage, otherwise known as me, will sign off on it. Okay? You need two parts. You need the magnitude and you need the direction. Then you're going to move an E-field sensor in there, middle of the charge, and get a reading of both magnitude and the direction. So you're going to take that E-field sensor and you're going to drop it in there. Then you're going to calculate the experimental error only in the magnitude of the reading. Okay? Only in the magnitude, not in the direction. So as best you can, you're going to come in here and you're going to drop an E-field sensor in the middle of that. As best you can estimate that where that is. And then, like for example, this is, 16.3, whatever that is. Okay? So you're going to kind of put that in the middle as best you can. And then you're going to say, hey, this is what the computer says it is. You're only finding the value, the experimental error in the magnitude, not in the angle. Okay? All right, so do that, and then we'll move on to part 5.